Hello everyone. In Lab 2, you're going to build an object model and a state transition model for something like a smart car. And your smart car could be based on a toy robot that essentially has a few sensors and a drive, or you can go all out and look up the types of things that Tesla has or any other smart car has, and see if you can think of how a state transition model would work on something like that. Of course, the more the sensors you have, the more complex the state transition model it would be. Something like that. This should be pretty simple, and I'll give you a few hints about some of the things that you can think about in this video. So this is the robot that I bought for my daughter for about 70 bucks. Of course, 70 bucks pays for just the chassis and some of the sensors. You do need um, Raspberry Pi that serves as the brains of the robot. You need a couple of lithium-ion batteries, the 18650 batteries that you can get pretty easily. So here are the different things that the robot has. It's got, of course, the primary drive is using four independent, what they call speed reduction motors. So these four yellow things which have a shaft directly connected to the wheels. So there is no transmission, there is no direct, no gears that you need to use. Now, of course, this means you can generate quite a bit of torque because this is, pure four-wheel drive. But at the same time, if you need to go forward, you have to turn all the wheels forward at about the same speed. If you want to go back, turn the wheels backwards at about the same speed. If you want to turn left, you're going to turn the right wheels forward and the left wheels back. And that's what's going to turn this thing left. And then the other way around to go right. Other sensors that it comes with, there are two photoresistors. So there's this one and another one on that side. Basically, it detects light, and I have more information about these sensors in the blog site that I created. It's got two ultrasonic transceivers. So one sends out an ultrasonic sound, and the other one waits for an echo. And based on that, it can tell how far a barrier is. It actually has a camera also in that mouth thing. It also has three IR sensors at the bottom. So um, these three are infrared transceivers. You can see that there is a pair in each of them. So essentially what this does is the same thing. It sends out IR signal down, and the other one waits for reflection. So it can tell if you have a light um, surface or a dark surface that you are driving on top of. So that's about all the sensors this has. In terms of output, it's got some gimmicky LED lights. So there are eight of these lights that you can essentially turn on any color, and so you can create quite a bit of color show with this with their app and with their API as well. In addition, it's got two servos that control the pan tilt mechanism for the camera and the ultrasonic sensors. It also has, I think in terms of output, that's about all it has. Oh, I forgot, there's a buzzer, uh, um, a very simple single frequency buzzer, kind of like a horn. So that's essentially all that comes with it. Now, as you can see, we have put in some mods. We have a couple of headlights that we have attached, tail lights with turn signals, and even a makeshift robot arm. So let me quickly give you a demo on how this works. So I'm turning on the Pi so I can show you some of the things that it can do. So when you turn this on, now I actually wrote code so I can control it with wireless keyboard like this one. And see, there goes the tail lights. So the tail lights are on. That means it's ready to be controlled. And as you can see, these are fully configurable. The headlights can come on and go off, so I can control that with my keyboard. I can also turn the tail light. The tail light's now programmed, so whenever you turn left, it will give you a left blink. When you turn right, it'll do a right blink, and when you turn back, it'll flash the LEDs. So that's basically what it has. I'm going to turn on the drive so you can kind of see how this works. So currently, obviously by default, since mostly my daughter plays with it, she uses this keyboard almost like a game controller. So you can drive it forward, drive backwards, turn left, turn right. You can use the controller to turn on the horn. You can also, as I showed you, to turn on the headlight and turn off the headlights. And you can also control this makeshift robot arm. So it's got 2 axes, 1 servo to control the arm going up and down, and the other servo to open and close the claw. Now, what you are going to do in this assignment is, first you're going to build an object model. So you think mostly in terms of the big items like the transmission, the control, right? So maybe transmission will have things like move forwards, backwards, turn left, turn right. You will control the sensor direction to forward or left or right. So you can actually turn this thing left or right. There is no way to, I have not programmed anything to control the front face left or right, but you will see, I'll show you the automatic drive that I have programmed. And finally, you would also use the inputs from the ultrasonic sensors, which go very simple with it. You don't have to worry about how an ultrasonic sensor works. Simply create a class that maybe has a method like get distance or something like that that you can call to see how far the barrier is. You can do the same thing with the IR sensors if you're using an IR sensor for your control. Now, what you want to create a state model for is entirely up to you. I want you to be creative. Think about what you can do to make this robot drive on its own. So I programmed something that looks like this. So now this robot is going to drive on its own. Let's see how it does. Let's just keep it straight for a second. So I'm not controlling it at all. So as you can see, I have programmed the face to turn left and right to look at how far the barriers are. And if it works well, it should be able to turn around, find barriers. And as you can see, it's not very smart. It just got stuck down there. So, it obviously depends on how robust the sensors are. One of the things that I would like to add is an accelerometer, so I can detect whether the robot is stuck somewhere. Right now, if it's stuck, if the wheels are stuck, there is no way for the system to know. So now it's essentially driving around. Whenever it sees a barrier, it tries to find its way out. So this is what you are programming, or you're building a state model for. So think about the different states of the system, what it would need to make sure that it can go and not run into something, and what are the different states it needs to go through. So if we obviously we are going to go over some of this during the next class. Remember, the lab is not due until next week, but I would still recommend that you look through, or at least think about the object model for this robot or any smart car that you choose. Okay, hope that helps.